All right, so 4.1 was your intro into trig. We talked about radians, how to graph them, how to convert from radians to degrees, how to find coterminal, how to find complement, supplement, and then ended with the length of an arc. So number 1 says to find 2 coterminal angles, 1 positive and 1 negative. If it's in degrees, how do I find coterminal? Add and subtract 360, right? So if I want a positive one, I'm going to add 360. And I get 480. And then negative, subtract 360. Negative 240. If it was in radians, what would you be adding and subtracting? 2 pi, good. All right, number 2 says find A, the complement, and B, the supplement of pi over 3. So complement means they add up to 90, which in this case would mean they sum to pi over 2. And then supplement would mean they add up to 180, which means pi. So with the complement, I'm going to do pi over 2 minus pi over 3. And then you've got to change them so they both have the same denominator. This time I can't, like one doesn't go into the other. So this would be 3 pi over 6. And this would be 2 pi over 6. And I get pi over 6. And then the supplement would be pi minus pi over 3. Or 3 pi over 3 minus 3 pi over 3, which is 2 pi over 3. If it was in degrees, what would you be subtracting from for the complement? 90. And if it was the supplement? 180. Good. All right. Then 3 says to convert the angle to radian measure. Remember, it might say like convert from degree to radian or vice versa. You've got to be able to determine how it's given to you. So 150 has to have the degree symbol if it wants it to be in degrees, like it does. If it would just said 150, you assume it's radians. Usually it's not that big, but you would assume it's radians. So if I'm going to convert, then I'm going to multiply by pi over 180. I can cross through my zeros, and then 3 goes into both of that. That'd be 5 and 6, and I get 5 pi over 6. Those answers will always be left exact. And then the last one says a circle has a radius of 7 inches. Find the length of the arc intercepted by the central angle of 210. So my formula for arc length is SOR, right? S equals theta times the radius, but what has to be true about the theta? Radians. Has to be in radians. So I'm going to first take that 210, multiply it times pi over 180. Again, I can cancel out my zeros. And then this time 3 goes into again. This would be 7 and 6. This is 7 pi over 6. And so I get 7 pi over 6 times my radius, which is 7, and this becomes 49 pi over 6. And it gave you a measurement this time, which is inches. God bless you. Again, those answers will usually be kept exact. Okay, more questions. This first one said to sketch each angle in standard position. So we talked about it yesterday, and we're going to dive a little bit deeper into the unit circle. But our quadrant angles are 0, pi over 2, pi, 3 pi over 2, and then it ends at 2 pi. So if I've got a angle that's in radians and you're not sure where it lies, then you want to figure that out in terms of where would it be in between 0 and pi over 2, and pi, that kind of thing. So 4/5 is obviously bigger than 1/2, right? But it's less than 1, which means it's in which quadrant? Quadrant 2. It's pretty close to the x-axis because it's just shy of it. So I can approximate it to be somewhere over there. B says 5 pi over 4. So now this is 1 and 1/4 pi. So I know I have to go past 1, but I'm not going to 1.5. It's smaller than 1.5. Which means it's in between the 1 and the 1.5, which would be 5 pi over 4, or third quadrant. Questions on those? Okay, then you got the angle. So we got one that was 3, you had one that was 7. What was the other one? Is that it? 2, okay. These are given to you in radians. So we said the way you find radians, remember all the way around your circle is 6.28. Which means just shy of that would be 6. If I have it go straight across, well, that's not straight across. If I have it go across the circle, then that means this is 3, which makes sense because half my circle is 3.14. So that's a little bit less than 3. Then I would divide this into 2 smaller parts. So I can come here, that's 2, here that's 1, and make those go across your circle. And that's your 4, 5, and we already have the 6 that's here. So now when I go to approximate where these lie, I can say that 3 would be here. That would be 3 radians. I can say that 7 is going to be past 6, right? A whole nother radian, which means it's going to go all the way around to where that 1 is, because that would be 6 plus 1 radian. That would be 7 radians. And then 2 would be where we approximated 2 to be. So that would be 2. These are approximations. My advice is if you get it on your quiz and you're given like the actual angle and asked you to approximate what the radian is go ahead and draw yourself out that little 6 to 3, 2 to 5, 1 to 4. Again, it's an approximate, but you should be able to figure it out from there. All right, and then this last one, what was this? This is complement, right? Mary Angel, this one was yours, right? Yeah. Is this complement, supplement? Or was it?
It was coterminal.
Coterminal, okay. So coterminal means I'm going to take that pi over 10 and I'm going to add 2 pi to it, which becomes 20 pi over 10 or 21 pi over 10. And then I'm going to take the pi over 10 and I'm going to subtract 2 pi from it, or 20 pi over 10. And I get negative 19 pi over 10. So one's got to be positive, one's got to be negative.
Wait, why would it be negative 19 then? Oh.
1 minus 20, right?
Oh, okay.
Yeah. All right, so in addition to your notes for 4-1, you also want to grab on that module the thing that says blank circle, because we're going to talk about the unit circle today. So you want to go back to Canvas, and you want to grab the thing that says blank unit circle. This is the unit circle, okay? It's basically what happens when a circle has a radius of 1. If the circle has a radius of 1, and I draw out my quadrant angles, which we already talked about, that establishes your 4 corners. And then what happens if my radius is 1 and I continue to make triangles as I move around this circle? So this theta here would be 30 degrees. My special right triangle when it's a 30, 60, 90 triangle is 1, root 3, and 2, if you remember your 30, 60, 90 triangles. And from there, you can make your sine, cosine, and tangent. So like opposite over adjacent, opposite over adjacent, adjacent over hypotenuse, and opposite over hypotenuse. And all of those make sine and cosine, which are these values here, which we'll dig further into in 4-3. For right now, we're just going to fill in the angles, okay? But that's where this comes from, which looks like this, okay? And we're going to fill it in together, and then you're going to do this for a quiz, well, partial quiz grade next week. So on the module, there's a thing that says blank unit circle. You want to open it up. We're going to fill it in together. And then you'll do the same next week. So I'm going to start with the quadrant angles we talked about yesterday. Notice that one of the lines has a degree symbol, one of them does not. So I'm going to start with the degrees. We'll start here. This would be 0. This would be 90. This would be 180. This would be 270. And then it doubles back around to the bottom part, which is 360. Then there's a pattern for the angles in between, and it goes 30, 15, 15, 30, and that pattern repeats all the way around your circle. So to 0, I'm going to add 30, and this would be 30. Then to 30, I'm going to add 15, and it's 45. 45, I'm going to add 15. It's 60, 30, and I stop at 90. So it's kind of like your checkpoint. Then I repeat that pattern again. 30 added to 90 is 120. 15, 135, 15, 140, no, 150, and 30, 180. And then I repeat the pattern again. 180 plus 30, 210, plus 15, 225, plus 30, 240, no, sorry, plus 15, 240, plus 30, 270. Again, another checkpoint. And then the last one, 30, 300, 15, 315, 15, 330, and 30, 360. So 30, 15, 15, 30, all the way around your circle. Good so far. Then comes the radians. So the radians, also we talked about the quadrant angles yesterday. 0 at the top was pi over 2. On the left was pi. On the bottom, 1.5 pi or 3 pi over 2. And all the way back around to 2 pi. Still with me? Okay, then the pattern for radians is the angle closest to your x-axis is over 6. So this goes over 6, this goes over 6, this goes over 6, this goes over 6. The angle closest to your y-axis is over 3. Over 3, over 3, over 3, over 3. And the in-between is over 4. Over 4, over 4, over 4, and over 4. Now the first quadrant is all just pi. So this is pi over 6, pi over 4, pi over 3, and they convert. So if you need to test an individual one, you can always convert from radians to degrees or degrees to radians. Then because this is 1, I need my denominators to be 1 less, my numerators to be 1 less than my denominator because it's close to 1 but not quite 1. So in the second quadrant, the numerator is 1 less than the denominator, which means this is 2 pi over 3, God bless you, 3 pi over 4, 5 pi over 6. In the third quadrant, it's 1 more because we've gone past 1. So 7 pi over 6, 5 pi over 4, and 4 pi over 3. And then in the fourth quadrant, it is 1 less than double, because that's what would make it 2. Or you can memorize the pattern of 5, 7, 11. 5 pi over 3, 7 pi over 4, 11 pi over 6. The only quadrant point we're going to fill in today is the only point we're going to fill in is the quadrant point. So if this has a radius of 1, then this means I'm moving to the right 1. What's that coordinate point? 1, 0. If I'm going up 1, 0, 1, left 1, negative 1, 0, down 1, 0, negative 1. We will come back and fill in the other coordinate points. You probably, hopefully remember them, but if not, we'll talk about how we get them first, and then we'll come back and fill those in. All right, now we're going to fill in all the coordinate points. So every over 6 is root 3 over 2 and 1/2. We're going to go back and adjust the signs, but every over 6 is root 3 over 2 and 1/2. Every over 4 is root 2 over 2 and root 2 over 2. And every over 3 is 1/2 and root 3 over 2, the reverse of the over 6. So that means that this first one is root 3 over 2 and 1/2, root 3 over 2 and 1/2, root 3 over 2 and 1/2, and root 3 over 2 and 1/2. Again, we're going to go back and add on the positive and negatives, but for right now, we're just filling in the coordinates. Every over 4 is root 2 over 2 and root 2 over 2. So root 2 over 2. And every over 3 is 1/2 and root 3 over 2. There are tons of other patterns and ways to remember this. Some people do the 1, 2, 3, or 3, 2, 1, 1, 2, 3, 3, 2, 1. I don't care how you memorize it, as long as you memorize it, okay? There's some other tricks that are on the iTunes U course that like previous students have filmed, like tricks that help them remember. Again, I don't care how you know it, as long as you know it. The faster you can recall it, the quicker things will go and the easier it's going to get from here on out. So now think about what happens in a quadrant, right? So if I'm in a standard coordinate grid and I'm in the first quadrant, what are the signs of x and y?
Positive.
They're both positive, right? So we're going to come back on here next week and add to this sine and cosine, but for right now we're just going to say they're both positive, x and y, which means I'm going to leave my signs alone. In the second quadrant on my coordinate grid, what are the signs?
Negative, positive.
Negative x, positive y. So positive y, negative x, that means every single x is going to get a negative in front of it. In the third quadrant, what are my signs?
Negative.
Both negative. So all of those coordinates get a negative. And in the fourth quadrant,
Positive, negative.
positive x, negative y. Easy stuff, right? How many of you could have filled that in before we went over it today? Very good. Okay, it's so important. And it's worth half of a quiz grade next week. So whatever it takes you to memorize it, you want to make sure you memorize it. Okay, again, we're going to change the positive negatives as you move around. We'll do sine and cosine there, but not yet. So the length of the intercepted arc is t, right, which is where this comes from. This is also the radian measure of the central angle. Thus, in the unit circle, the radian measure of the central angle is equal to the length of the intercepted arc. So all it's saying is that this would be the same as if I had that circle as x squared plus y squared equals 1. All the way around my circle, that's where those points come from. Again, we're going to get back to the points later. But that's what makes up your x, y. All right, the 6 trig functions that you should know are sine, cosine, tangent, which we remember from like geometry. And then cosecant, secant, and cotangent. So sine and cosecant are reciprocals, cosine and secant are reciprocals, and tangent and cotangent are reciprocals. Sometimes we switch these around. Don't do that, okay? That's the biggest mistake people make here. Think the C and the S never go together. C goes with S, S goes with C. Never C with C and S with S, okay? And then tangent and cotangent, literally the word tangent is in cotangent, so you don't usually screw those up, okay? If you're looking at coordinate points around your unit circle, if you've got x, y, then the sine is the y, the cosine is the x. Because your tangent is opposite over adjacent, which would be the makeup of that y and x. Your tangent is y over x. And then the reciprocals. So the reciprocal to sine is cosecant, which means 1 over y would be cosecant. The reciprocal to cosine is secant, which would be 1 over x. And the reciprocal to tangent is cotangent, which means x over y. All right, so example 1 says use the figure at the right to find the trig functions at t. So t is just your angle. So if this is my coordinate point, 1/2 and root 3 over 2, I want to find, if it says the trig functions, it means all 6. Sine t, cosine t, tangent of t, and then cosecant of t, secant of t, and cotangent of t. So we said sine was which coordinate point? The y, which would be root 3 over 2. Cosine, x, 1/2. Tangent, y over x, so root 3 over 2 over 1/2. And then I keep, change, flip, and I get root 3. With me so far? Okay, so for cosecant, I flip sine. 2 over root 3. Can you leave a root in the denominator? Nope, we're going to rationalize. Multiply by root 3 and root 3. And I get 2 root 3 over 3. Secant, I flip cosine. This is just 2. And cotangent, I can either do x over y, or I can flip, which this would, root 3 would be over 1. So it'd be 1 over root 3, and then rationalize it. So here's my sine, cosine, tangent's root 3, cosecant, secant, and cotangent. So you will never leave one of these answers unrationalized. You got to make sure you rationalize it. You're never going to leave something in the denominator that's a square root. And not for this one, because this one obviously doesn't reduce. But if you get to the point that you have triangles, you need to make sure that every answer is reduced. Find the point x, y in the unit circle that corresponds to the real number t. So this time it's giving you 2 pi over 3. First of all, as soon as you see the over 3, you should know your coordinate point is 1/2 and root 3 over 2. So that you want to memorize, and you want to know it to be able to recall every over 3, every over 6, every over 4, as long as it's reduced, because obviously that can change if it's reduced. Then I want to figure out, where is 2 pi over 3? First, second, third, or fourth quadrant? Second quadrant. It's bigger than a half, less than a whole, right? So it's in that second quadrant, which means my x is negative and my y is positive. And that's the x, y that corresponds to that spot. So even if you're not great on your signs, you should be able to do the recall on any over 3, any over 4, any over 6, and then any over 2 as well. Okay, example 3 takes it the step farther. Find, if possible, the sine, cosine, and tangent of the real number. So we have to know the angle, which is 2 pi over 3. Know the coordinate point there, which we just said was negative 1/2 and root 3 over 2. And then from there, find the sine, the cosine, and the tangent. So the sine is the y, which is root 3 over 2. The cosine is the x, which is negative 1/2. The tangent is y over x. So root 3 over 2 over negative 1/2. Keep, change, flip. And I get negative root 3. B says negative pi over 3. So now my sign is negative, which means I go the other direction. Which quadrant would negative pi over 3 be in?
Fourth.
The fourth quadrant. It's going to be the first over 3 you hit as you're moving in the negative direction, right? We already know the point, though. It's still 1/2 root 3 over 2. We just got to figure out the signs. If it's in the fourth quadrant, x is positive, y is negative. So my sine is now negative root 3 over 2. My cosine is 1/2. And my tangent, it's still over 3, which means I already have, it's root 3. One's positive, one's negative.
Can I ask you a question?
I think somebody's out. Oh, no. Yeah. Chris is out.
Someone's out.
Yeah. All right, then C says 6 pi over 3. What's different with that? This can be reduced, right? This is 2 pi. So my coordinate point at 2 pi was 1, 0. What's the sine? 0. What's the cosine? 1. Tangent would be 0 over 1, which is 0. If it was the other way around, that's why it says, if possible, you can get something that's undefined. Questions so far? All right, domain and range of sine and cosine. So the domain of the sine function and the cosine function is the set of all real numbers. This is because you can literally take and go around that circle an infinite amount of times, and your numbers are going to range from 0 to positives to negatives, all sorts of numbers that fall within there. Sine and cosine are periodic, which means that the functions behave in repetitive or cyclic manner. The period for each is 2 pi, which means every coterminal angle will have the same values for their trig functions. So if I had something like pi over 3, which we already said our coordinate point was 1/2 of root 3 over 2, then every coterminal angle to pi over 3, so if I add 2 pi or add 6 pi, that would be 7 pi over 3. It's also the same angle. Subtract 6 pi, I get negative pi over 5 pi over 3. It's the same angle. So you're just going around your circle. So this is pi over 3. 7 pi over 3 would be around one more time. Negative 5 pi over 3 would go in the negative direction, but it still lands in the same spot. So thinking about that, if I asked you for the coordinate point at 2 pi, you would tell me it's what? What's the coordinate point on the right there? 1, 0. How about pi? Negative 1, 0. Which means, actually let me put this over here so as not to confuse you. So we've got 2 pi on the right and pi on the left, which means every even whole number is going to have that same coordinate point, 1, 0. I could have 22 pi. It's going to be in the same location. I could have 322 pi. It's going to be in the same location. Right-hand side, coordinate point 1, 0, which means all my trig functions follow that. Every odd whole number falls on the left side, which would be that negative 1, 0. 3 pi on the left. Okay, 33 pi on the left. 233 pi still on the left-hand side. Even whole numbers are on the right, odd whole numbers on the right, on the left. All right, so example 4 says evaluate the trig function using its period as its aid. Usually when it says that, it means it's bigger than 2 pi. So 13 pi over 6 is obviously bigger than 2 pi. In mixed number format, what is 13 pi over 6? 2 and pi over 6, or 2 and 1 pi over 6, right? So 2 takes me all the way around my circle. 1 pi over 6 past it stops at where pi over 6 is, and that coordinate point is root 3 over 2 and 1/2. The sign there would be what? 1/2. 5 pi is my positive, sorry, not my positive, but my whole number that is what? Even or odd? Odd, which means I can go this is 1, this is 2, this is 3, this is 4, this is 5. Or I could just remember that odd whole numbers fall on the left, which means my coordinate point there is negative 1, 0. And the cosine of that would be what? Negative 1. Still with me? Okay, even and odd functions. So cosine and secant are called even functions because even if I change the sign on the inside from positive to negative, the value does not change from positive to negative. And if you think about why this happens, let's pick 2. Let's pick pi over 6 and let's pick negative pi over 6. What's the coordinate point at pi over 6? All the over 6's is root 3 over 2 and 1/2. So in the first quadrant, it stays that way. In the fourth quadrant, what's my coordinate points? Root 3 over 2, negative 1/2. So if I'm looking at the cosine, am I looking at the x or the y? X. Do you notice that both of these are positive? The sign does not change, right? If I flip them and make them the reciprocals for the secant, will the sign change? No. Same exact thing would happen over here. If I did 5 pi over 6 and I did negative 5 pi over 6. Actually, let me do that. I would get negative root 3 over 2 and 1/2 and negative root 3 over 2 and negative 1/2. So the sign on the cosine, again, does not change, which means the sign on the cosecant would not change. On the secant, sorry. Every other function the evens and the negative and the positive angles are going to have different signs. So sine and tangent, which means they're reciprocals, cosecant and secant. If I look at the sine, I'm going from 1/2 to -1/2, the sign changes. If I'm going from over here, 1/2 to -1/2, the sign changes. And then because tangent is the reciprocal of them, the tangent here would be positive. Here it'd be negative. Here it'd be negative. Here it'd be positive. So the tangent, the sine, and their reciprocals, which are cosecant and cotangent, are called odd functions. They will change sign. So if I gave you that the sine of an angle like t is 2/3, then the sine of the negative angle would be -2/3. The cosine of an angle like t being 2/3, the cosine of the negative angle doesn't change. It stays the same sign. Tangent of an angle changes. So sine and tangent and their reciprocal functions change, but cosine does not. This is going to come into play now and then when we get to verifying trig functions. So even and odd are important. Okay, our reciprocal function. So we're going to talk about identities, like verifying identities soon. And the first kind are those even and odd identities. These are the reciprocal functions, which we already talked about. Sine is the same thing as 1 over cosine, or cosecant. Cosine is the same thing as 1 over secant. Tangent, 1 over cotangent. Cosecant, 1 over sine. Secant, 1 over cosine. And cotangent, 1 over tangent. These are called reciprocal identities. The last ones would be even and odd. All right, so this just says find the value of the trig function to evaluate the indicated functions. So in A, I give you the cosine of t is -1/2. What would be the cosine of negative t? What happens when I change the sign on the angle if it's cosine? It doesn't change, which means -1/3. And then the secant would be the reciprocal of cosine, right? So I'm saying the secant of negative t, which means look back on the cosine of negative t and flip it. This is -3. B says the sine of negative t is 3/5. So the sine of t would be what? -3/5. Okay, sine and tangent change signs. If the angle changes sign, the function changes sign. And then the cosecant of t would be -5/3. For this last example, you're going to need a calculator. So I'll show you how to do it on both a scientific and a graphing calculator. The most important thing here is making sure that you're in the right mode. So you have to identify what kind of angle you're trying to find the trig function of first. Is it in radians or it's in degrees? Remember that degrees will have your actual degree symbol. So if it said sine of 32 degrees, it would actually have that little degree symbol, then you'd know it's degrees. None of these have that. So this, and this are all in radians. To get your calculator from degree to radians on the graphing one, you're going to go to where it says mode. You're going to click where it says mode on your calculator. And you're going to see the third thing in the line is radian to degree. So you want to make sure it's in radians. If you have reset your calculator, it automatically goes back to radians. So I'm going to keep it in radians. I'm going to quit this menu. And then secant is not an actual function that's on my buttons. The buttons I have are sine, cosine, and tangent. But what we do know is that secant is the same thing as 1 over cosine. So I'm going to do 1 over cosine of 4.5. 1 divided by cosine, which is the button that has the COS, 4.5. And I get -4.7439. Now, cosine -1 is not the same thing as secant. Those are different buttons. That's the button for when you want to try to find the actual measure of the angle if you're given the function. So you want to make sure you're not hitting that. All right, so B says cosecant of 1 over 9, which is 1 over sine of 0.9. So So 1 divided by sine 0.9, which is 1.2766. And then tangent is actually the button that's on our calculator. We're going to do tangent, and you're going to make sure you use pi, not 3.14. So tangent, your pi button, which is over the caret on a graphing calculator, second pi divided by 2. And I get an error. So if you think about why this happens, tangent at pi over 2 would be at the top of my unit circle. Pi over 2 is here. This would be 0, 1. Tangent would be y over x, or 1 over 0, which is undefined. So your calculator is trying to yell that at you. It just does it in a different way. And then the last one is cotangent. So this is going to be 1 over tangent, negative 1.2. And I get negative 0.3387, or 38877, which is 3888. Now from a scientific calculator like this one, the mode is here. I want to click mode, and then you want to make sure that you're on radians, which is in that top. I'm going to second quit, and then I can do all the same thing. 1 divided by, and my cosine, again, the button's there, cosine 4.5. And I get the same answer. 1 divided by sine, that button's here, 0.9. Same answer. Tangent of pi divided by 2. The pi is here where it says HIP, right here, HYP, divided by 2. Again, it gives you an error because that's undefined. And 1 divided by tangent, negative 1.2. Oh. And I get that last answer. Okay, that wraps up our intro into unit circle. We'll continue with right triangle angles and that kind of stuff in 4-3. Have a good day.